Lesson 5.1, Expressions versus Equations. So we've talked about the difference between these two before, but now we're going to really make sure that this distinction is clear. So we've got two things written at the top, the super scary black cat, and then the super scary black cat jumped on my couch. So the difference between those two is pretty obvious probably to you. This one is considered a phrase, and this one is considered a sentence. But what really makes the difference between those two? Well, this is just kind of incomplete. It doesn't have any sort of verb or ending to its sentence. It's just saying the super scary black cat. The second one has a verb, the word jumped, on my couch, and a final punctuation. So those two things are what make this a sentence. And so when you're looking at mathematical phrases versus mathematical sentences, that is indeed the difference between an expression and an equation. So this first set of three here are all going to be considered expressions. And that is because they are incomplete thoughts. So the first one I have is x plus 3. The second one I have is 3 plus 4, and then the third one a little bit longer. So x plus 3 I really can't do anything with. I can't simplify it and I can't evaluate it unless I had a value for x. So I could evaluate if x equals 2, in which case I would have 2 plus 3 and that would give me 5. So I could evaluate it if x equals 2. The second one I could also evaluate. I could just do 3 plus 4 equals 7, and that too would be evaluating an expression. The final one you can't evaluate again unless you have a value for x. But if I didn't have a value for x, I could actually simplify this. So the directions might say simplify the following expressions, in which case I would underline all of the like terms, and then I would underline all of the constants. Do you remember that vocabulary word? And I would get 15x plus 25. So that's a bit more simplified. Now, if I look at the bottom set of, let's see if I can extend the page. If I look at the bottom set of three, now these are going to be considered equations. I'll label them below. And the difference is similar to the sentence and phrase we looked at above. This one has an equal sign in all three, and another side to the equal sign, an answer, which isn't quite parallel to punctuation, but similar. So I've got 3 plus 4 equals 7. Well, that just shows you that two sides are equal, they're balanced. There's nothing I can really do with this equation except for say, yes, that's true. The second one, x plus 4 equals 10, I can, however. I can solve for x. And that is what directions would say when it's referring to an equation. Solve for x. Well, that means, well, what value can I come up for x that would make that sentence true? So think about it. Oh, right, x equals 6. And that means if I put a 6 in there, I'd have 6 plus 4 equals 10, which would be a true statement. Now the final one, 2x plus 4 equals 10, can you think of something that x could be that would make that equation true? Well, we're going to learn how to solve that formally, but I think you could probably think through it. If I double a number and then I add 4, I'm going to get 10. My answer would have to be 3. Because if I multiply 2 times 3, I get 6. I add 4 more, and I get 10. So when you're working with equations, you're solving for an unknown variable. An equation has an equal sign and an answer. An expression, you can either evaluate if x equals some value, or you could simplify if you had some distributive property or combining like terms. Okay, moving on. This is the actual definition of both. Expression is a mathematical phrase that does not have an equal sign or an answer. One can simplify or evaluate an expression. So in this case, no equal sign, no answer. I could simplify this. I could distribute and get 6x plus 3 and recopy the remainder of my expression. And then I can combine like terms and get 12x and combine my constants plus 9. And that is the most I can do with that expression. That would be considered more simple. Oops. Now, if I look at my equation, it's a mathematical sentence that has an equal sign and an answer. One can solve for an unknown value of a variable in an equation. So 3 plus x equals 17. My goal is to figure out what value can I put in for x that will make this sentence true. Well, if you think about it, you probably would come up with x equals 14, which would work right there. Okay, moving on. Actually, I need to move to the next page. Now you're going to be doing, in this section, you're going to be doing a lot of translating. So you have to go back to remembering what words mean addition, what words mean subtraction, what words mean multiplication, division, and equals. Well, there's all the obvious ones: plus, minus, multiply, divide, equals. But then there's some that I wanted to point out to remind you about. The word sum is always referring to an addition sentence. You could use words like more or increase. And I know we've brainstormed many of these words before. Subtraction, the word that would be the same sort of word as sum for subtraction is difference. So when you're referring to a subtraction problem, you could use the word difference to do that, to explain that. You could also use the word decrease or less. And again, there's many, many more. A word that would go with multiplication would be product. Wouldn't want you to forget that one. And another one is double, triple, quadruple, things like that. And then one that's frequently forgotten is the word of. And I'm going to say it as much as I can so that you get that ingrained in your brain. The division symbol would be divide, split, and quotient, the answer to a division problem. Equals is obvious. You could have equals, but also just the word is. 3 plus 4 is 7. The same as. That would also be equivalent. So things like that. There are many, many more of all of these, but this should get you started for the chapter. Thanks.